Science has always promised us a map. For centuries, we believed that if we could just name every force and weigh every particle, the universe would finally become a legible book. We told ourselves a very specific story, that causes led to effects, that the past is a locked vault, and that time, this relentless, invisible river, only ever flows in one direction. We built our entire civilization, our sanity, and our very identities on that one single rule. But what happens when the universe refuses to follow the script? What do we do when a lab result appears that isn't just a discovery, but a disturbance? In late 2024, inside a quiet laboratory at the University of Toronto, a team of researchers wasn't looking to build a time machine. They were doing something far more clinical. They were watching photons, individual particles of light, pass through a cloud of ultra-cold rubidium atoms. On paper, it was a standard investigation into quantum timing. But when the data began to flicker across their screens, it didn't just challenge their expectations. It felt like a crime scene. The crime wasn't a theft of matter, but a theft of duration. To understand what happened, you have to imagine the scene at the microscopic level. Picture a single photon as a pulse, a packet of energy traveling through the void. It approaches a dense, ghostly cloud of atoms. When that light enters the cloud, it interacts with the atoms, exciting them, essentially spending time inside that atomic fog before exiting the other side. Under normal conditions, this takes a tiny but measurable amount of time, a few nanoseconds, a fraction of a heartbeat. But as the researchers adjusted their instruments, the timeline began to fracture. They weren't just seeing the light move quickly, they were recording something that our language isn't even designed to describe. According to their measurements, the photons were exiting the atomic cloud before they had even finished entering it. If you were to look at the clock the atoms were keeping, the duration the light spent inside the cloud wasn't just zero. It was negative 62 nanoseconds. It sounds like a rounding error, a glitch in the software. But this wasn't a mistake. It was a repeatable, verified, physical reality. The experiment was essentially screaming at the researchers. The light was already gone, before it arrived. When this news hit the social web, the law engine ignited instantly. Headlines began to proclaim that physics had finally broken reality, that we had finally achieved the impossible and reversed the arrow of time. The internet heard negative time and immediately translated it into time travel. We wanted a story of a universe where we could undo our mistakes, where the future could reach back and touch the past. We wanted the mystery to be as big as our imaginations. But here is where the war begins. The war between the equations and the story. If you ask the physicists what happened, they will give you a description that is, in many ways, even more unsettling than a simple time machine. They will tell you about negative group delay. They will explain that a photon isn't a solid little ball, but a wave of probability. And when that wave hits the atomic cloud, the cloud actually reshapes the wave. It reconstructs the pulse on the other side so efficiently that the peak of the light pulse appears to leap forward in time. In the cold, hard language of mathematics, nothing is broken. The equations hold firm. Causality, at least in the way we use it to send signals, remains intact. The universe hasn't allowed us to send a text message to the past. But the story we tell ourselves, the folk intuition that time is a steady, independent flow that everything must obey, is what lies in ruins on the laboratory floor. Because even if the math is safe, the physical reality is haunting. How can a particle spend a negative amount of time anywhere? If we say a duration is negative, we are effectively saying that the particle existed in the after state before the before state had even concluded. It suggests that our concept of now is nothing more than a convenient fiction. This is the first massive gap that traditional science documentaries usually skip. They focus on the spooky action, the weirdness of light being in two places at once. But they ignore the terrifying implication of the Toronto result. That time itself is not a fundamental property of the universe. It is a variable. And like any other variable in a quantum equation, it can be flipped, stretched, and even subtracted until there is less than nothing left. The researchers themselves find themselves in a strange position. They are the detectives standing over the body of common sense. The lead experimenters have spoken about this ambiguity, how the result is both mathematically sound and intuitively impossible. They stand inside that gap, characters in a world where the maps no longer match the terrain. They warn us not to leap to time travel, but they cannot stop the feeling that we are looking at a version of reality that is far more porous than we ever assumed. If a photon can spend negative time in a cloud of atoms, then what is duration? Is it possible that time is not a river we are floating in, but a record we are creating? Think about the implications of that for a moment. We think of time as the thing that allows change to happen. But what if it's the other way around? What if change happens first and time is just the label we use to make sense of the chaos? In the Toronto experiment, the atoms were changed by the light. The record of that change, the excitation, is what we measured. And that record told us a story that defied the sequence of the event. It suggests that the universe doesn't care about our before and after. It only cares about the state of the system. We are the ones who insist on stringing those states together into a timeline, like frames in a movie. But every so often, the projector skips. A frame appears out of order, and for a brief, terrifying moment, we see the machinery behind the screen. We see that the movie isn't real, only the light is real. This result is just the beginning. It is the first crack in the dam, because once you accept that the duration of an event can be negative, you have to ask, what else have we been wrong about? If the now is this fragile, what happens when we look even deeper? What happens when we stop looking at particles moving through space and start looking at the very structure of the timeline itself? We have lived for centuries in the comfort of the standard rules. We believed that if you fired a gun, the bullet travelled the distance and then it hit the target. Measurement was just a way of watching it happen. But the Toronto experiment tells us that the act of measurement, the interaction between the light and the atoms, is what defines the event itself. And that definition can defy the arrow of time. This isn't a story about magic. It's a story about the edges of knowledge, where our language begins to hesitate. We are like the 19th century doctors who first saw an X-ray of a human hand. They didn't see a medical tool. They saw a ghost. They saw a hidden interior that made the solid world feel like a veil. Today, we are looking at negative time and seeing the ghostly architecture of the universe. We are realizing that the invisible is not empty. It is waiting for a different kind of vision. As we move forward into this investigation, we have to leave our intuition at the door. We have to be willing to ask the questions that feel like they break reality. Because if the Toronto result is real, and it is, then the floor beneath our certainty is much thinner than we ever imagined. The universe is not a clockwork mechanism operating independently of us. It is a conversation, and in that conversation, the future and the past are already starting to speak at the same time. If negative seconds can exist in a lab, then the entire history of the cosmos is suddenly up for negotiation. And the next experiment we uncover won't just subtract time. It will suggest that our choice to look at the world today is what created the past billions of years ago. The projector hasn't just skipped a frame. It's starting to run the film in reverse. And we are just beginning to realize that we are the ones holding the remote. If you were to walk into the laboratory at the University of Toronto during the height of the negative time experiments, you wouldn't see a flashing DeLorean or a swirling vortex. You would see a room filled with the hum of cooling systems, the smell of ozone, and a group of people in lab coats staring at a series of jagged green lines on a monitor. These scientists are the most dangerous people in the room, not because they've built a weapon, but because they're currently engaged in a desperate, silent war. It is a war between the equations they trust and the story the rest of us want to tell. This is the second great fracture in our understanding of time, the moment where the ghost enters the machine. When the headline, "Physics ran an experiment on time," first began to trend, the world didn't react with a request for peer-reviewed data. It reacted with a collective gasp of recognition. We have been primed for this for a century. We've been told by movies and novels that time is a fragile thread that can be snipped or knotted. So, when a lab report mentions negative seconds, our brains immediately bypass the math and go straight to the myth. We want to believe that the future has finally reached back to change the past. But if you ask Ephraim Steinberg, the lead researcher behind the result, he will tell you something that sounds, at first, like a disappointment. He will explain that they didn't actually reverse time in the way a movie character might. He will talk about group delay. He will use words like phase and reconstruction. He is attempting to be the anchor, trying to keep the ship of science from being swept away by the tidal wave of public imagination. In the laboratory's view, what happened was a masterpiece of quantum manipulation. They weren't moving a solid object backward. They were managing a wave of probability. Think of the photon not as a bullet, but as a long, shimmering pulse of light. As this pulse enters the cloud of rubidium atoms, something called anomalous dispersion occurs. The cloud essentially reshapes the pulse, it amplifies the front end, and dampens the back end so efficiently that the peak of the light appears to emerge on the other side before the peak has even entered. To a physicist, this is a technical triumph. It's a trick of perspective, like a magician making a coin appear in his hand before he's even reached for his pocket. The negative duration is a mathematical value assigned to how the light's centre of mass shifted during its interaction with the atoms. In this version of reality, the map is fine. The equations are safe. The universe is still a logical cause and effect machine. But here is where the ghost enters. Because even if the physicists are right, even if it is just pulse reconstruction, the physical reality of the experiment remains deeply unsettling in a way that the equations cannot fully wash away. To prove the negative time wasn't just a trick of the light, the researchers looked at the atoms themselves. When a photon passes through a cloud of rubidium, it excites the atoms. It leaves a tiny, measurable mark, a signature of its presence. If the photon really spent negative time in the cloud, then the atom should show evidence of that interaction before the photon had even finished its journey. And they did. The data suggested that the atoms were being affected by the light in a sequence that defied our internal clocks. This is the ghost in the machine. It's the realization that while the equations might be safe, the experience of the universe is not. We are witnessing a phenomenon where the record of an event, the memory held by the rubidium atoms, is being written before the event has concluded. This creates a massive gap in the outlier videos you've seen before. Those videos usually tell you that science proved time travel, or they tell you it was all just a math error. Both are wrong. The truth is far more haunting. Physics didn't break reality. Our headline culture broke physics. We took a highly specific, laboratory-controlled anomaly and used it to build a new religion of time. This is the war of words. The term negative time was never meant to be a literal description of a clock running backward. It was a provocative label, a demolition charge placed under the floorboards of common sense. But once that label left the lab, it mutated. On Reddit threads and in fringe forums, this wasn't an experiment in group delay. It was proof that we live in a simulation where the rendering engine has a look-ahead feature. It was proof that death is an illusion because the past is still active. The scientists find themselves in the role of the antagonist in their own story. They are trying to tell us that the world is still solid, while their own data keeps whispering that it's porous. They are like architects trying to convince you a house is safe while you can clearly see the walls are made of smoke. They insist that no information is being sent into the past, which protects the law of causality. But they cannot explain why the universe allows for a negative duration at all. If time is a fundamental flow, negative should be an impossible value. It should be like trying to have negative distance or negative mass. The fact that the value exists and that we can measure it with atomic precision suggests that our folk intuition of time is not just incomplete, it's a hallucination. We think we are moving through time like a boat moving through water. But the Toronto experiment suggests that we are actually the water. There is no independent river of time. There is only the interaction. There is only the record. This leads us to a deeper, unanswered mystery that the successful transcripts completely ignored. If negative time is just a phase shift in a wave, then why does the universe require such a complex mechanism to protect its secrets? Why is there a no signaling theorem at all? It's as if the universe has a built-in firewall. It allows the impossible to happen in the dark. It allows light to exit before it enters. It allows atoms to remember the future. But the moment we try to use that information to change our lives, the firewall of noise and entropy slams shut. We are standing in the middle of a cosmic negotiation. On one side, we have the standard rules that keep our sanity intact. On the other, we have the quantum reality, which shows us that the sequence of events is a flexible, fragile thing. The Toronto result didn't give us a time machine. It gave us something much more valuable, a mirror. It shows us that our obsession with breaking reality is actually a desire to find a way out of the now. We use these experiments to justify our theories about simulation, about the block universe, and about retro-causality because we are desperate for the universe to be as non-linear as our own memories. We want the world to work the way our hearts do, where a trauma from the past can be healed by a realization in the future. The ghost in the machine isn't the photon. The ghost is us. We are the observers who take a green line on a monitor and turn it into a story about the end of time. We are the ones who look at a 62 nanosecond delay and see the collapse of the Roman Empire or the chance to save a lost loved one. As we move deeper into this documentary, we're going to stop looking at the green lines and start looking at the firewall itself. Because the next experiment didn't just look at how light moves through a cloud of atoms. It looked at how we measure that light. And it found that the very act of looking, the simple click of a detector, is the only thing preventing the past from being rewritten every single day. The war between the equations and the story is about to get much, much louder. Because we've just discovered that the cost of keeping time is much higher than anyone ever imagined. And if we stop paying that cost, the reality we know won't just break, it will simply vanish. To understand why the latest experiments have left the physics community in a state of quiet panic, we first have to acknowledge the one story we all thought was settled. For nearly a century, the double-slit experiment was the ultimate campfire story of science. It was the spooky baseline. We were told that if you fire a particle at a barrier with two holes, it somehow passes through both at once, interfering with itself like a ripple in a pond, until the moment you decide to watch it. The moment you look, the mystery collapses. The wave becomes a particle. The ghost becomes a thing. For decades, we treated this as a mystery of space. We focused on the where. Where is the particle? Which path did it take? But in 2023, a team of physicists decided that looking at the where was a distraction. They realized that if reality is truly broken, the fracture isn't just in the layout of the room, it's in the ticking of the clock. They didn't use a wall with two holes, they used a wall of time. This is the transition from spatial physics to temporal geometry, and it is the missing piece of the puzzle that almost every other documentary on this niche completely ignores. Most people are still stuck in 1927, arguing about particles and waves. But the new frontier isn't about where an object is, it's about when the universe allows it to exist. Imagine a mirror. Normally, a mirror reflects light because of its physical properties, but the researchers used a specialized material called indium tin oxide, the same stuff in your smartphone screen, and they did something radical to it. They hit it with an ultrafast laser, changing the material from transparent to reflective in a fraction of a trillionth of a second. They didn't cut holes in a piece of cardboard, they cut slits in the timeline itself. They opened a window of reflection, closed it, and then opened a second window nanoseconds later. 2 pulses of light were sent toward these time slits. In a world governed by common sense, these 2 pulses should have just bounced back as 2 distinct flashes. But that isn't what happened. When the researchers looked at the light that returned, they didn't see 2 pulses. They saw a diffraction pattern. But because this experiment happened in the dimension of time, the pattern didn't appear as stripes on a back wall. It appeared as a shift in the color of the light itself. The light had changed its frequency. It had interfered with its own past and future versions. This is what we call temporal interference, and its implications are far more haunting than the original double-slit experiment. In the original version, we learned that matter is a wave. In this version, we are learning that time itself is a medium that can be carved, modulated, and folded. Think about the sheer audacity of that result. In our everyday lives, we treat time as the ultimate, unchangeable background. It is the stage upon which the play is performed. You can move the actors, you can change the scenery, but you cannot move the stage. But the 2023 time-slit experiment suggests that the stage is actually made of the same pliable, ghostly material as the actors. The related and better secret that competitors missed is this. If light can interfere with itself in time, then the now is not a solid point. It is a porous membrane. We used to think that the interference pattern in the double-slit experiment proved that a particle could be in 2 places at once. The temporal double-slit suggests something even more radical. An event can be in 2 thens at once. When that light hit those 2 windows in time, it didn't just arrive and leave. It entered a state where its identity, its very colour, was determined by the relationship between 2 different moments. The before and the after were communicating to decide what the light should look like in the now. This brings us to the war between equations and story that we discussed earlier. The equations describe this as a shift in the frequency domain. They treat it as a technical byproduct of rapid material modulation. It's clean, it's safe, it's just math. But the story this experiment tells is one of a universe that is fundamentally unfinished. If we can create interference in time, it means the timeline has a geometry, and if it has a geometry, it can be manipulated. We are moving away from the idea of time as a flowing river and toward the idea of time as a time-slit reality, a series of shutters opening and closing, where what we perceive as a solid continuous existence is actually a high-speed flicker of interference patterns. This is the forbidden rung of the explanation ladder. If the universe is rendering its temporal geometry based on these interference patterns, then our sense of a smooth linear history is a total illusion. We are living in the frequency domain of a much deeper structure. The social web has already begun to weaponize this law. On the deeper threads of the internet, the time-slit result isn't just a lab curiosity, it's the smoking gun for the simulation theory's refresh rate. They argue that if you can cut slits in time, you've found the frames of the film. You found the gaps where the rendering engine pauses to calculate the next state of the world. But even without the fringe theories, the verified science is enough to make the floor feel thin. We've discovered that we can treat time exactly like we treat space. We can reflect it, we can diffract it, and we can force it to overlap. This means that the arrow of time, that relentless one-way street we all fear, might just be a specific setting of the geometry we're currently in. If we can change the frequency of light by opening and closing windows in time, what happens when we start doing that to more complex systems? What happens when we realize that the reason we can't see the future or the past isn't because they don't exist, but because we haven't learned how to create the right interference pattern to make them visible? The 2023 experiment wasn't just about light hitting a screen. It was about the realization that time is not a void, it is a fabric. And for the first time in human history, we have the scissors. We're no longer just floating in the river. We are starting to build the dams and the diversions. But as we began to carve into the timeline, we hit a wall, a cost that no one saw coming. Because it turns out that cutting into time isn't free. Every time we try to measure the when, the universe demands a payment in the form of entropy. And that payment is exactly what gives time its direction in the first place. We've seen the negative seconds, we've seen the slits in time. But to understand why the reality breaks, we have to look at the receipt. We have to look at the 2025 Oxford result, which proved that the act of keeping time is an act of destruction. And if you want to know the true price of a second, you have to look at the clock that actually eats the world it's trying to measure. Imagine a universe that is fundamentally lazy. For centuries, we assumed that time was a free background service, a universal clock provided by the cosmos that ticks away regardless of whether anyone is there to hear it. We believed that the past and future were distinct territories, and that the arrow of time was a fundamental law, as fixed and immutable as the speed of light. But in 2025, a team at the University of Oxford conducted an experiment that turned this comfort into a debt. They discovered that time isn't a free flow, it has a price, and every time you try to measure a single second, the universe sends you a bill in the form of destruction. This is the expensive click, and it represents the most significant gap in our understanding of reality. While other documentaries are busy arguing over whether you can kill your grandfather in the past, they are missing the much deeper, much more unsettling truth that the very act of knowing what time it is may be what is creating the direction of time in the first place. To understand the Oxford result, you have to look at the world's smallest clock. The researchers didn't use gears, springs, or even a digital display. They built a microscopic device out of a double quantum dot, a pair of tiny islands of electrons. They watched as electrons tunneled from one dot to the other, creating a tick at the quantum level. But they weren't just measuring time, they were measuring the cost of measuring time. What they found was a staggering imbalance. The internal ticking of the clock, the actual physical process of change, required a very small amount of energy. But the moment they tried to read that clock, the moment they recorded a result, the energy cost and the entropy generated skyrocketed. The act of measurement was hundreds of times more expensive than the event itself. In the language of physics, entropy is disorder. It is the tax we pay to the second law of thermodynamics, the rule that says everything eventually falls apart. We have always been told that the arrow of time exists because entropy increases. Things go from order to chaos. Eggs break, but they never unbreak. But the Oxford experiment suggests something far more radical. The arrow of time isn't a property of the egg. It's a property of the person watching the egg break. If we don't record the event, the ticking remains thermodynamically cheap. It is reversible. In the quantum shadows, the electron can tunnel back and forth, existing in a state where before and after haven't quite decided which is which. But the moment we generate a record, the moment the detector clicks and the information is amplified into our world, we create a massive surge of entropy. We buy a direction for the timeline. We force the universe to choose a now and an after, and we pay for that choice with irreversible chaos. This is the war between the equations and the story. The equations tell us that, on a fundamental level, the laws of physics are time-symmetric. They work just as well backward as they do forward. There is nothing in the math of an electron that says it must move toward the future. But the story we live in, the one where we grow old and memories fade, is a one-way street. The Oxford result suggests that the only reason our story has a direction is that we are constantly, obsessively taking notes. Think about what this means for the nature of existence. If the arrow of time is fueled by the creation of records, then time itself is an emergent property of information. It isn't a river we are floating in, it's a bridge we are building as we walk across it. Every click of a detector, every saved file on a hard drive, every fossilized bone in the earth is an anchor point. These records are what carve the universe into a past and a future. This is why the negative time results from Toronto and the time slits from the recent past are so confusing to us. In those experiments, we are operating in the gaps between records. We are looking at light before it has been fully written into the history of the world. In that twilight zone, the rules of cause and effect are still negotiable, but the moment we try to bring that information into our macroscopic reality, the firewall of entropy slams down. We pay the price, and the timeline becomes fixed. Most people think of a record as a passive reflection of an event. You take a photo of a sunset because the sunset happened. But the Oxford law suggests that the relationship might be inverted. The sunset only becomes a definitive, localized, directional event in the history of the universe because it was recorded by a camera, by a bird's eye, or by the heat absorbed into the pavement. Without the expensive click of record keeping, the universe stays in a state of superposition, where the timeline is a blur of possibilities. This leads us to a mystery that has haunted philosophy for centuries. What is a record? Is it just a human thing? If a tree falls in the forest and no one is there to hear it, does time still flow for that tree? The Oxford researchers suggest that consciousness isn't the key. Measurement is. Measurement is any interaction that amplifies quantum information into the large-scale world. It's a detector clicking. It's a crystal forming. It's an atom being excited in a cloud of rubidium. The universe is a vast machine for creating records. And because it is constantly recording its own state, through gravity, through light, through heat, it is constantly generating the entropy required to keep the clock moving forward. We are living in a universe that is burning through its own order just to maintain the illusion of a sequence. But here is the new information that changes everything. If the arrow of time is a product of entropy and measurement, then it is not universal. In isolated systems, where the expensive click hasn't happened yet, time can be made to stand still or even run backward. We've seen this in quantum computers, where researchers have reversed the aging of a single qubit. They aren't traveling through time. They are simply preventing the record from being written. They are avoiding the tax. This creates a terrifying possibility for the future of physics. If we can learn to manipulate the cost of time, we might be able to create pockets of reality where the arrow of time doesn't apply. We could build systems that exist outside of the narrative of before and after, but the price would be absolute isolation. To live without the arrow of time is to live in a world that can never leave a trace. It is to exist in a story that can never be told. We have spent our entire lives trusting that time is a solid, objective fact. We thought it was the one thing we could never lose. But the Oxford result shows us that time is something we are actively producing. It is a byproduct of our curiosity. We are the ones demanding to know when, and the universe is responding by burning its own potential to give us an answer. Every time you check your watch, you are participating in the destruction of the universe's original symmetry. You are making the now real, and in doing so, you are pushing the past further away into the unreachable distance. The record is written. The entropy is paid. The click has happened. But as we look closer at these records, these anchors of reality, we find that they are not as stable as they seem. Because if a record creates the past, then what happens if we find a way to erase the record? What happens to the history of a particle when the expensive click is undone? To answer that, we have to move beyond the clock and into the vault. We have to look at the record keeper's universe, where the very fabric of our history is being rendered in real time, and where the past is only as certain as the data we have left. The projector is still running, but the film is starting to look like it was edited by a ghost. We have reached a point in our investigation where the ground doesn't just feel thin, it feels like it has vanished entirely. We've seen the negative seconds in Toronto, we've seen the slits cut into the timeline itself, and we've seen the staggering tax the universe demands every time we try to measure a single tick of the clock. But now we have to ask the most dangerous question of all. If the arrow of time is merely a byproduct of creating a record, what happens to the universe when no one is keeping the books? This is the transition from physics to something much deeper, the concept of the record keeper's universe. For centuries we looked at the cosmos as a finished work, a grand architecture where the past was a solid foundation and the future was a building yet to be constructed. We assumed that the past was a physical place we had left behind, a trail of breadcrumbs leading back to the Big Bang. But the latest experiments suggest a reality that is far more fragile and, frankly, far more haunting. They suggest that the past isn't a place at all. It is a set of data that only resolves when it is forced to. To understand this, you have to look at what a record actually is. In our human world, a record is a journal entry or a photograph. But in the quantum world, a record is any interaction that amplifies information from the tiny, trembling scale of atoms into the large, heavy scale of our everyday lives. It is the expensive click of a detector. It is the alignment of a magnet. It is the specific way a crystal preserves the story of the pressure and heat that created it. The 2025 Oxford result gave us the receipt for existence, proving that reading a clock generates hundreds of times more disorder than the ticking itself. But the massive law gap that most science documentaries miss is the why. Why is the universe so obsessed with the cost of information? The answer lies in the realization that matter is historical. In the quiet machinery of the lab, researchers have found that certain systems do not simply return to silence after they are disturbed. They carry traces. They follow a different path home depending on where they've been. This means the present moment isn't just a reaction to current forces. It is a layered experience, carrying the shadows of every arrangement that came before it. But here is the twist: if those traces, those records, are never made, the before and after remain in a state of blurred possibility. We've lived with the fiction of clean separation, believing that the world just is, whether we are there or not. But the record keeper's universe suggests that without the click, without the record, the timeline has no direction. It has no arrow. It is a sea of hidden activity, a background trembling with events that haven't quite decided if they've happened yet. This changes the way we look at everything from a fossil in the ground to a memory in our heads. We used to think a fossil was a remnant of a past that was real. Now, we have to consider the possibility that the fossil is the anchor that makes that past real. By providing a durable, irreversible record in the present, the fossil carves a specific narrative into the history of the universe. It renders the past billions of years to match the evidence we hold in our hands today. It is a complete inversion of our intuition. We think the past creates the record, but the math is whispering that the record creates the past. Think about the implications for the now. If the arrow of time is fueled by the creation of records, then we are not passive observers watching a movie unfold. We are the ones holding the pen, and every time we notice something, every time we measure, categorize, or remember, we are finalizing the script of the previous scene. This is where the war between equations and story reaches its fever pitch. The equations of quantum mechanics are perfectly happy to let time run in both directions. They don't see a difference between an egg breaking and an egg unbreaking. But our story, the human story, requires a sequence. It requires a before that is gone and a future that is coming. The Oxford result suggests that we are paying for that story with entropy. We are burning through the universe's original symmetry, creating chaos and heat just to keep the now from collapsing back into a blur. We are essentially paying the universe to keep the projector running. This leads to a chilling realization that the social web has been obsessed with. If time is a record, then reality is fundamentally informational. On the deeper threads of Reddit and in the fringe podcasts, this is treated as the ultimate proof of a simulation. They argue that the universe only renders the parts of history that are currently being queried by a detector or a conscious mind. They see the delayed choice results and the negative seconds as glitches where the rendering engine didn't quite fill in the frames fast enough. But you don't need a simulation theory to be disturbed by this. The verified science is strange enough. It tells us that what we call identity or substance is actually just a record of passages endured. The universe isn't a collection of objects, it's a conversation between the things we notice and the things we almost miss. If we stop noticing, if we stop recording, does the universe lose its history? The experiments with time crystals and zero-point energy hint at a reality where motion continues without energy input, where systems exist partially outside the normal temporal flow. These are the forbidden rungs on the ladder. They show us that when we manage to avoid the cost of measurement, the arrow of time starts to wobble. The now begins to lose its sharp edges. We are like the early doctors looking at the first X-rays. We are looking beneath the skin of reality and seeing a ghostly architecture. We are seeing that solidity is a partial truth. The real structure of the world isn't made of matter. It's made of the persistent traces that matter leaves behind. But if the record is what anchors the past, what happens if the record is erased? We've seen that in the quantum eraser experiments. If you destroy the which path information, the particle behaves as if it never took a path at all. It reverts to a wave. It rewrites its own history. If this is true at the level of photons, the logic must scale. It suggests that our entire history is only as certain as the data we have left. If every record of an event were to be wiped from the universe, every memory, every data trace, every physical consequence, the event wouldn't just be forgotten, it would be unhappened, it would return to the sea of possibilities, a frame deleted from the film. The universe is a vast, self-recording machine, but it is also a machine that can be made to forget. And as we've discovered in the latest quantum computing trials, information can indeed be destroyed. It can vanish from our universe entirely, leaving no trace in any system we can access. When that happens, we aren't just losing data, we are losing a piece of the timeline. This is the true mystery of the Record Keeper's universe. We are living in a reality that is being rendered in real time, built upon a foundation of records that we are constantly creating and occasionally destroying. The past is not a locked vault. It is a living, breathing negotiation between the evidence of today and the possibilities of yesterday. We have spent this investigation looking at how physics breaks reality, but perhaps it's time to admit that reality was never what we thought it was. It wasn't a machine, it was a memory. And as we move into the next chapter, we're going to look at the most controversial idea of all, that the future isn't just waiting for us. It is already here, reaching back through the dark and helping us decide what the past was supposed to be. If the record keeper can be influenced by the end of the story, then the expensive click isn't just a payment for the present, it's a message from the future. We have now reached the point in our investigation where we must step onto the most dangerous rung of the ladder. In the previous chapters, we looked at how time can be slowed, how it can be subtracted, and how it can be carved into slits. But all of those anomalies still allowed us to cling to one final comforting rule. That cause always comes before effect. We told ourselves that even if the clock is weird, it still only ticks in one direction. But in 1999, an experiment was finalized that took that rule and shredded it in front of our eyes. This is the story of the delayed choice quantum eraser, and it is the moment where the universe stops being a machine and starts behaving like a ghost story. To understand the gravity of what happened, you have to picture the crime scene. In a laboratory at the University of Maryland, researchers led by Yoonho Kim set up a game of cosmic cat and mouse. They used a specialized crystal to split a single photon into two entangled twins. They named them the signal photon and the idler photon. These two particles are essentially two halves of the same soul. Whatever happens to one is instantly reflected in the other, no matter the distance. The researchers sent the signal photon on a very short, very simple path. It traveled a few centimeters and crashed into a detector. Its journey was over in a fraction of a nanosecond. Its position was locked. Its history was written. But the idler twin was sent on a much longer, much more convoluted journey through a maze of mirrors and prisms. The maze was designed to give the idler photon a choice. At the end of the maze, there were detectors that would reveal which path the photon took, the which path information, but there were also eraser detectors. If the photon hit these, its path information would be scrambled so thoroughly that it would be impossible to ever know which route it had taken. The choice was essentially, do I reveal my history or do I hide it? Here is where the timeline breaks. Because the idler's path was much longer, the signal photon had already hit its detector and finished its life before its idler twin had even reached the part of the maze where the choice was made. When the researchers looked at the data, they found something that shouldn't exist. If the idler photon eventually hit a detector that revealed its path, the signal photon, which had already landed nanoseconds earlier, showed up as a simple, solid particle. But if the idler photon eventually hit an eraser detector that hid its path, the signal photon, again, having landed in the past, showed up as a wave. The conclusion is unavoidable and terrifying. The choice made by the idler photon in the future seemingly reached back in time and dictated how the signal photon behaved in the past. When this result hit the public, it triggered a massive cultural fracture. This is the forbidden rung of retrocausality. One camp looked at the data and saw literal time travel, proof that the future can rewrite the past. The other camp, the skeptics, retreated into the safety of the equations. They argued that there is no backward signal. There is only a correlation between entangled twins. They claimed that the past wasn't changed, it was simply undetermined until the full circuit of information was closed. But as an elite YouTube storyteller, I have to point out the massive gap that both of those groups are missing. They are both trying to force the universe back into a linear story. One says the future moves backward, the other says the past waits. But there is a third option, an obscure deep law theory that makes time travel look like child's play. It is called the two-state vector formalism, pioneered by physicists like Yakir Aharonov. In this view of reality, the universe isn't just pushed from the past by the Big Bang, it is also being pulled from the future by a final boundary condition. Imagine the universe as a handshake. One hand is reaching out from the beginning of time, and the other hand is reaching back from the end of time. What we experience as the present is simply the place where those two hands meet. If this is true, then the delayed choice experiment isn't changing the past. It's revealing that the past was never just a result of what came before it. The past was always a negotiation between where we started and where we are going. The signal photon didn't wait for its twin. It was already part of a completed circuit that included the future measurement. This is the new information that the outlier videos ignore. They want to sell you the sensation of a broken timeline, but they don't want to deal with the implication of a symmetric timeline. If the future is already reaching back to influence the quantum states of today, then our entire concept of free will and agency is under siege. It suggests that the end of your story is already exerting a subtle, ghostly pressure on the beginning. But if that's true, why can't we feel it? Why can't I use this quantum connection to send the winning lottery numbers to my younger self? This is where the universe reveals its most sophisticated defense mechanism, the no signaling theorem. It is the cosmic firewall. In the delayed choice experiment, if you look at the signal photons detector in real time, you don't see a wave or a particle. You see a fuzzy blob. It looks like random noise. It is only after you get the data from the future idler detectors and use them to sort the past hits that the patterns emerge. The universe allows the future to influence the past, but it encrypts that influence in noise. You can only read the message from the future once the future has already become the present. You are allowed to live in a haunted house, but the ghosts are forbidden from speaking to you in a language you can understand until they've already moved in. This is the war between the equations and the story. The equations show a perfect, time-symmetric handshake. The story we live in shows a one-way street. We are trapped in the story because we lack the keys to decrypt the noise of the now. But think about what this does to the concept of the record keeper's universe we discussed in the last chapter. If the future is participating in the creation of the past, then the records we find today, the fossils, the light from distant quasars, the memories in our cells, are not just remnants of a dead history. They are the results of a high-stakes negotiation with a future that hasn't happened yet. John Wheeler, the legendary physicist who first proposed these delayed choice scenarios, suggested that we are part of a participatory universe. He imagined a giant U where the eye at one end looks back at the beginning of time at the other end. By looking at the Big Bang today, we are finalizing the physical laws that allowed the Big Bang to happen billions of years ago. We are not just watching the movie, we are the editors, sitting in the future, cutting the film of the past to make sure the plot makes sense. The forbidden rung tells us that the universe is not a sequence of events. It is a single, massive, interconnected state. Our perception of time is just a result of our inability to see the whole handshake at once. We see the fingers of one hand and call it yesterday. We see the palm of the other and call it tomorrow. But the experiment in the lab proves that it is all one hand. As we prepare to move deeper, we have to ask, if the past and future are in a constant state of negotiation, then what is now? Is the present moment just the friction caused by those two timelines rubbing against each other? In the next chapter, we're going to look at the block universe, the idea that every moment you've ever lived and every moment you ever will live is currently existing in a frozen four-dimensional diamond. Because if the future can reach back and touch the past, then the only way to save our sanity is to admit that change itself might be the greatest illusion ever performed. The experiment didn't just break reality, it showed us that we've been looking at the map upside down. The future isn't coming for us, it's already here, and it's been waiting for us to notice it. Since the beginning of time, we have spent this entire journey looking for the moment when the timeline breaks. We've chased negative seconds through clouds of rubidium and watched as future choices seem to reach back and rewrite the past. We've treated every experiment like a crime scene, a fracture in the steady, predictable flow of our lives. But now, we have to face the most unsettling possibility of all. What if the reason these experiments seem to break reality is that our fundamental concept of time, the idea of a flowing now, was never real to begin with? This is the transition into the eternal now, the concept of the block universe, and it represents the ultimate war between the equations and the story. In our everyday lives, we live by a very specific narrative. We feel that the past is gone, the future is yet to be, and the present is a tiny moving point of light, the only part of reality that is actually real. We call this presentism. It is the framework for every memory we hold and every plan we make. But if you look at the math that actually governs the cosmos, from Einstein's relativity to the latest quantum results, that moving now is nowhere to be found. Instead, the equations describe something else entirely. A four-dimensional block where every moment of your life, from your first breath to your last, exists simultaneously. Imagine the universe not as a movie being projected onto a screen, but as the entire roll of film sitting in the canister. In the film roll, the beginning, the middle, and the end all exist at once. They're all equally real, equally solid. The only reason we perceive a sequence is because our consciousness is like the projector's lamp, moving along the frames one by one. This is the block universe theory, and the experiments we've been discussing aren't breaking it. They are the final, undeniable proof of its existence. This is the massive law gap that most successful transcripts completely ignore. They want to sell you the sensation of changing the past, but in a block universe, you can't change the past because the past isn't back there, it is over there. Take the Toronto negative time experiment. To us, it looked like a photon exited a cloud before it finished entering, a violation of the sequence. But in the block universe, that photon's entire path, the entry, the negative delay inside the atoms, and the exit, is a single, static shape in four-dimensional space. It's like a curve in a glass sculpture. The photon didn't travel through a sequence, it simply occupies a specific, complex geometry in the block. The negative duration isn't a reversal of a flow, it's just a particular fold in the fabric of the diamond. The same applies to the time slits and the delayed choice paradoxes. When we say a choice today dictates a particle's path billions of years ago, we are using the language of a moving now. We are trying to force the universe to act like a story that is being written as it goes. But the block universe suggests that the handshake between the past and the future isn't a message travelling through time. It is the structural integrity of the block itself. The entire history of that photon, from the distant quasar to the astronomer's telescope tonight, is a single, completed thread. The choice and the path are not two events separated by time. They are two parts of the same physical object. This is the forbidden rung of eternalism. It suggests that reality is globally fixed. While we, the local observers, are busy panicking over retro-causality and broken reality, the universe is sitting perfectly still. We are like ants walking across a massive finished masterpiece, thinking the colours are appearing as we move our legs, when the painting was finished eons ago. But this realisation brings a new kind of haunting. If every moment already exists, then what happens to becoming? What happens to the idea that we can choose our own futures? In a block universe, the future is just as unchangeable as the past. Your 80th birthday is currently existing in the block with the same degree of realness as the cup of coffee you had this morning. You aren't going to get there. You are already there. You are just currently focused on this specific coordinate. This is where the war of words becomes a war for our sanity. We find these experiments disturbing because they threaten our sense of agency. We want to live in a world where the future is an open book, but the physics of the eternal now suggests the book is already printed, bound, and sitting on a shelf. The broken parts of these experiments are just the moments where we catch a glimpse of the pages we haven't read yet. There is a deeper, more obscure twist to this law that is rarely discussed. Some physicists argue that the reason we experience a flowing now at all is because of the expensive click we discussed in Chapter 4. They suggest that the creation of records, the entropy we generate by measuring the world, is what creates the illusion of time's arrow within the static block. We are like a person with a flashlight in a dark museum. The museum is the block universe, where everything is already on display. But because we can only see what the flashlight hits, and because the act of using the flashlight creates heat and disorder, we mistake our movement for the creation of the world. This leads to a profound human resonance. If the block is real, then nothing truly vanishes. We are historical creatures, as the sources say, not because we leave a trail of dead moments behind us, but because we are extended through time like a mountain range is extended through space. Your childhood isn't gone. It is just located at a different set of coordinates in the 4D diamond. Death, in this view, isn't an end. It is simply a boundary of your physical shape in the block. The internet has taken this idea and run toward a high retention, almost religious conclusion, that death is an illusion. They argue that if the past still exists, then everyone we've lost is still there, suspended in their own coordinates of the eternal now. This is the ultimate comfort that the broken reality headlines offer. We aren't looking for a time machine to change things. We are looking for a way to believe that the things we love are permanent. But the scientists stand in the gap, offering a more disciplined form of wonder. They warn us that even if the block is static, we are still bound by the no signaling theorem. We can't see the other parts of the block at will. We are stuck in our slice, forced to experience the sequence, even if we know it's a fiction. This is the tragedy of the block universe. We have discovered the true nature of reality, but that discovery doesn't set us free. It only shows us the walls of our perspective. We have learned that the now is a provincial illusion, a mental shape we inherited to help us survive. But as we look at the temporal slits and the negative seconds, we are realizing that our inherited shapes are too narrow for the universe we actually inhabit. We are not participants in a story that is being told. We are participants in a structure that already is. But if the block is a finished masterpiece, then who is the one looking at it? If the film is already in the canister, who is the one running the projector? This brings us to the most controversial rung of all. Because if the universe is globally fixed, but we experience it as a rendering, then we have to ask if the projector is something fundamental to the universe itself. In the next chapter, we're going to look at the rendering engine. We're going to ask if these experiments don't just prove the block universe, but prove that the universe calculates itself only when it has to. Because if the frames are already there, why do they only seem to light up when we look at them? The diamond is static, but the flicker is real. And the secret of that flicker is what finally breaks the border between physics and the simulation. If the block universe is a finished masterpiece, a static four-dimensional diamond where every moment of your life is already etched in stone, then we are left with a haunting mechanical question. Why does it feel like a movie? If the film is already in the canister, who is running the projector? And why does the light only hit one frame at a time? This is the point where the investigation takes its most controversial turn. We have to move beyond the hardware of space-time and start looking at the software of reality. We have to talk about the rendering engine. In the world of high-end game design, there is a technique called procedural generation, or frustum culling. To save processing power, the computer doesn't render the entire world at once. It only calculates the pixels you're currently looking at. The mountains behind your character don't actually exist as fully realized objects until you turn around. This is efficient, it's logical, and according to a growing number of observers on the deeper edges of the social web, it is exactly how our universe handles the problem of time. This is the deferred rendering theory of reality, and it is the only framework that seems to make sense of the broken experiments we've uncovered. When we look at the 2023 temporal double slit, where light interferes with its own past through shutters in time, or the 2024 Toronto results, where photons exit an atomic cloud before they've finished entering, we aren't seeing time travel in the way a sci-fi novel describes it. We are seeing the universe backfilling the data. We are seeing a system that doesn't finalize the details of an event until a measurement forces it to produce a result. Think about the delayed choice quantum eraser we explored. It tells us that a particle's path isn't decided until the idler twin hits a detector nanoseconds, or even billions of years later. To a simulation theorist, this isn't a paradox. It's just lazy evaluation. The universe is simply waiting to see if it needs to render a particle or a wave based on the specific query we send to the system. Until that query is made, the information stays in a state of unrendered probability. It's a way for the cosmos to keep the frame rate high without wasting energy on details no one is watching. But here is the new information that the successful outlier videos missed, the piece of the puzzle that turns a fun metaphor into a terrifying physical possibility, the Oxford 2025 result. Remember the expensive click? The researchers proved that the act of reading a clock, of creating a record, generates a massive surge of entropy. It is hundreds of times more costly to measure the time than it is for the time to pass. If we apply the rendering engine framework to this, the expensive click is the write-to-disk cost. In a computer, it's cheap to keep data in the temporary, volatile memory of RAM. But the moment you want to save that data permanently to the hard drive, it takes a significant amount of energy and physical change. The Oxford result suggests that the universe behaves exactly like this. The quantum superposition, the state where everything is a blur and time has no direction, is the RAM. It's fast, it's cheap, and it's reversible. But the directional, irreversible arrow of time is what happens when the universe is forced to commit that data to the permanent record of history. We are living in the write-to-disk phase of a cosmic calculation. This is the bridge between the equations and the story. The scientists will tell you that this is just the nature of decoherence and thermodynamics. They will say that information is a physical quantity, and that moving it from the quantum scale to the macroscopic scale naturally creates heat. They are trying to keep the mystery inside the lab. But the story the internet has built out of this result is far more addictive. They argue that if the universe has a specific, measurable energy cost for making reality permanent, then reality itself must be a finite resource. We are living in a system with a limited budget. This shifts the narrative from what is time to why is time so expensive? On Reddit and in the fringe Discord servers, the discussion has evolved into a hunt for glitches. They point to the Toronto negative time results as a look-ahead buffer error. In video streaming, your computer often downloads the next few seconds of a video before you play them, so the transition is smooth. Simulation theorists argue that the Toronto experiment caught the universe doing exactly this. By creating a negative group delay, the researchers essentially peeked into the buffer. They saw the peak of the light pulse because the system had already calculated its arrival, even though the physical entry hadn't been fully processed by the local clock. It is a demolition charge under the ordinary idea of a solid world. If the universe renders on demand, then the past isn't a foundation we are standing on. It's a file that is being updated in real time to match the measurements we make today. When the astronomer looks at the light from a quasar billions of light years away and decides to measure it as a wave, the rendering engine goes back billions of frames and adjusts the history of that light to ensure the present-day interference pattern is consistent. The history isn't a sequence of events, it's a consistency check. This leads us to the most unsettling part of the rendering engine theory, the observer. In a video game, the world only renders because there is a player looking at it. This has led many to make the radical leap that consciousness is the GPU of the universe. They argue that we are the ones providing the processing power that forces the blurry quantum shadows to resolve into solid objects. This is the participatory universe taken to its ultimate technological conclusion, but the verified science offers a more disciplined, if equally haunting, alternative. The observer doesn't have to be a person, it can be anything that creates an irreversible record. a detector click, a chemical reaction, or even the expensive click of an atomic clock. The GPU isn't our minds, it's the physical process of amplification. The universe isn't rendering for us, it's rendering for itself to maintain its own logical integrity. We are just the characters in the game who have finally noticed that the textures on the distant mountains are a little bit blurry. We've started running experiments that push the draw distance of reality to its absolute limit. We are firing photons through time slits and measuring negative seconds. And in doing so, we are watching the rendering engine struggle to keep up. We are seeing the moments where the code of the universe has to cheat to preserve the illusion of a smooth timeline. This is why the result breaks reality. It doesn't mean the world is ending. It means the world was never what we thought it was. It means that solidity is a budget-saving feature, and time is a directional record created to manage the overflow of information. As we look at these glitches, the negative nanoseconds and the retrocausal erasers, we have to realize that they are not errors in the universe. They are the keys to its true architecture. We have been so obsessed with the story of our lives that we never stop to look at the medium that makes the story possible. But if we are living in a rendered reality, and if time is an expensive record created by measurement, then there is one final terrifying question we have to answer. In any system, whether it's a computer or a cosmos, if you continue to increase the complexity, if you continue to create more and more records, eventually you run out of memory. We've seen how physics breaks reality in the lab. But what happens when reality breaks on a global scale? What happens when the expensive click becomes more than the universe can afford? To understand the end of the script, we have to look at the war of words, the moment where our headlines and our cultural obsession with these experiments might actually be the thing that pushes the rendering engine to the point of collapse. Welcome to the front lines of the war of words. By now, we have travelled through the most unsettling corridors of modern physics. We've seen time subtracted in Toronto, carved into slits in London, and revealed as a static four-dimensional diamond by the math of the block universe. But as we stand here, surrounded by the wreckage of our common sense, we have to confront a final, uncomfortable possibility. What if the reason reality feels broken isn't because the universe changed its rules, but because our language is no longer capable of describing the truth? If you were to step out of the high-energy environment of the laboratory and into the screaming chaos of the social web, you would see a transformation that is almost as strange as the experiments themselves. This is what we call the mutation of the claim. In the lab, a researcher like Ephraim Steinberg is careful. He uses phrases like negative group delay or post-selected quantum timing. He's a man standing inside an ambiguity, trying to hold on to the guardrails of peer-reviewed data. He isn't trying to build a headline, he is trying to map a flicker on a screen that no one expected to see. But the moment that technical result hits the digital air, it undergoes a violent evolution. Negative group delay becomes negative time. Negative time becomes time travel. And time travel becomes the result that breaks reality. This is the first major law gap that almost every other documentary on this niche completely ignores. They focus on the spooky result, but they ignore the war of words, the fact that we are currently living through a semantic crisis. We are witnessing a relay race of ontological embarrassment, where every generation of physicists produces a result that doesn't actually violate the laws of the universe, but does violate the story we tell ourselves about those laws. To understand this war, you have to meet the antagonist of our documentary, the skeptic. This isn't a person who hates science, but a person who fears the collapse of clarity. The skeptics argue that the breaks reality tone of these headlines is nothing more than a language problem. They claim that negative time is just a provocative label for a mathematical phase shift, a clever way of naming a quantity that behaves weirdly under specific conditions. To the skeptic, the universe is perfectly safe, perfectly logical, and perfectly boring. They believe that headline culture didn't discover a broken reality. Headline culture broke physics. But here is where the war gets interesting. Even if the skeptic is right, even if negative time is just a label, we have to ask ourselves, why did we choose that label? Why does the human mind, when faced with an abstract quantum correlation, immediately drive an entire mythology through the gap? It is because we have an intimate, desperate inability to leave ambiguity alone. We do not fear the mystery because it's dark. We fear it because it is familiar. When we hear that a photon arrived before it finished leaving, we don't want to hear about anomalous dispersion. We want to hear that the past is negotiable. We want to believe that the standard rules of the 19th century, the world of solid objects and predictable paths, was a lie. We have made a religion out of the lab result. In this new religion, the delayed choice quantum eraser is the gospel of the second chance. The Toronto negative time result is the prophecy of the eternal present. We take these precision measurements and we flatten them, removing the math and the caveats until they become a new kind of popular cosmology. We do this because we evolved to survive a world of stones, faces, and winters, not a world of quantum fields and time slits. Our inherited mental shapes are too narrow for the universe we've discovered, so we stretch our words until they snap. This is the semantic misdirection. We use the language of science to justify the feelings of the heart. We say retro-causality when we mean hope. We say block universe when we mean permanence. The verified science tells us that the universe is non-local and relational, but we translate that into everything is connected because we are terrified of being alone in the vacuum. And the universe, in its strange silent way, seems to be in on the joke. Think about the no-signaling theorem, the cosmic gag order we've discussed. The universe allows these broken events to happen. It allows the future to influence the past and light to travel at negative speeds. But it refuses to let us use that information to change our lives. It's as if the universe allows the impossible to exist only in the dark, but the moment we try to speak about it in a language that would give us power, the moment we try to send a message to the past, the firewall of noise slams shut. We are allowed to see the ghost, but we are forbidden from talking to it. This is the true central tension of modern physics. It isn't just about matter and energy, it's a study in intellectual maturity. It asks whether we can remain devoted to the truth without demanding that the truth stays simple. It asks whether we can handle the disciplined wonder of a reality that refuses to sit still for our metaphors. The successful outlier videos want to tell you that the world has ended and a new one has begun. They want to sell you certainty. But the real story is that we are caught in an uneasy gap between what we can test and what we can truly comprehend. We are like the doctors of the late 1800s looking at the first X-rays. We see the ghostly architecture of the hand, and we realize that the solidity of the world is only a partial truth. But we don't have the words yet to describe the inside of the universe. So we fight the war of words. We argue on Reddit over whether the past is being rewritten or if it's just conditional sorting of data. We battle over whether the expensive click proves that consciousness creates time, or if it's just a technicality of thermodynamics. We are trying to tune our instruments to a frequency that is just beyond our reach. And that is why these experiments continue to haunt us. They aren't just technical milestones, they are encounters with humility. They remind us that the universe is under no obligation to resemble our intuition. It doesn't care about our categories of wave or particle, before or after, then or now. Those are the labels we use to feel oriented in a reality that is far broader, stranger, and less obedient than we ever comfortably assumed. The war of words isn't a distraction from the science, It is the science. It is the sound of a species trying to enlarge its mind to fit the scale of its discoveries. We are revising our stories because the facts have outgrown them. As we prepare to close this investigation, we have to realize that the break in reality isn't a catastrophe. It is an invitation. We are being asked to become larger than the mental shapes we inherited. We are being asked to listen to the faint frequencies of the cosmos, to the noise that hides the pattern, and to the silence that carries the record of everything that has ever been real. In the final chapter, we are going to look at the new map. We are going to stop asking if the universe is broken and start asking what kind of seeing is now possible. Because if time doesn't work the way we thought it did, and if the now is just a record we are paying for with entropy, then the end of the script isn't a conclusion. It's a beginning. The projector is still running. The light is still hitting the screen. But for the first time, we are no longer just watching the movie. We are starting to understand how the film was made. And the first thing we've realized is that the director has been waiting for us to notice the edits all along. At the end of all the experiments, all the equations, and all the careful attempts to pin the universe to a page, what are we actually left with? We started this journey with a headline that sounded like an obituary for common sense. Physics ran an experiment on time. The result breaks reality. We looked for the crime scene, and we found it everywhere. We found it in a lab in Toronto, where light arrived before it finished leaving. We found it in London, where time was cut into slits like a piece of paper. We found it in Oxford, where the very act of reading a clock was revealed to be a slow-motion act of destruction. But as the dust settles, we have to realize that we weren't witnessing a catastrophe. We were witnessing an enlargement. For centuries, we believed we were masters standing above the universe, looking down at a giant clockwork machine. We assumed that time was a universal background service, a free flow that didn't care whether we were there or not. We lived by the standard rules, safe in the belief that the past was a locked vault and the future was a void yet to be filled. But every unsettling result we've uncovered has been a correction, not just of our theories, but of our temperament. We were forced to admit that the universe is under no obligation to arrange itself around the scale of human intuition. We evolved to throw stones, to read faces, to survive winters, and to remember paths home. We did not evolve to naturally grasp quantum fields, to watch space-time warp, or to see the deep history written in the background radiation of the cosmos, and yet we reached for them anyway. That is perhaps the most remarkable fact of this entire story. A species shaped by hunger, fear, and time has built instruments capable of detecting whispers older than the Earth. We have argued with reality, revised our metaphors, and continued forward even when the answers made the world feel less familiar than it was before. The break in reality is actually a mirror. It shows us that we've been looking at the map of time upside down. We thought we were floating in a river, but we've discovered that we are the ones creating the current. Think back to the expensive click of the Oxford clock. We learned that time gains its direction, its arrow, only when we create a record. This means that the now is not a fundamental property of the universe. It is a byproduct of our curiosity. We are the ones demanding to know when, and the universe responds by burning its own potential to give us an answer. Every time you measure, every time you remember, and every time you notice a flicker on a screen, you are participating in the creation of the timeline. You are the record keeper in a universe that only resolves when it is forced to speak. This is the new map of reality. It isn't a map of objects in space, it is a map of relationships in information. The negative seconds in the Toronto lab weren't a glitch in the software of the world. They were a glimpse of the buffer, the state of possibility that exists before a record is finalized. The retrocausal handshake from the future wasn't a violation of causality. It was a demonstration that the past and the future are in a constant, living negotiation. We are no longer just watching a movie that was finished eons ago. We are the editors, sitting in the present, helping to finalize the script of the previous scene by the way we choose to look at the world today. This realization is the forbidden rung that finally lets us step off the ladder of confusion. We don't have to choose between a world that is broken and a world that is boring. We can choose a world that is participatory. John Wheeler, the man who dreamed up the cosmic double-slit experiment, imagined the universe as a giant U. On one side is the Big Bang, the beginning of all things. On the other side is the I, the observer, the record keeper, the mind. By looking back at the beginning of time today, we are the ones who finalize the physical laws that allowed the beginning to happen in the first place. We are the ones who ensure that the expensive click of existence actually happens. This is why the war of words we discussed in the last chapter is so important. We shouldn't fear the headlines that claim reality is broken. We should see them as the growing pains of a species that is finally outgrowing its folk intuition. We are moving from a machine-like understanding of time to a conversation-like understanding. In a conversation, the last sentence can change the meaning of the first. In a conversation, silence is just as important as the words. And in the conversation between us and the cosmos, we are finally starting to listen to the frequencies that are pitched just beyond our reach. The true legacy of these experiments is not that they shattered physics, but that they deepened it. They turned science from a search for simple certainty into something much wiser, a disciplined wonder. We've learned to stay rigorous and careful while remaining open to the impossible. We've learned to say, this is what we know, this is what the evidence allows, and this is where the darkness begins again. And if the unknown continues to recede as we approach it, that isn't a sign of failure. It is the mark of a living universe, a universe that keeps inviting us forward, not with final answers, but with deeper and more beautiful forms of attention. So does the result break reality? No, it breaks the illusion of our separation from it. We are not masters standing above the universe, but participants within it, listening from inside the mystery rather than outside it. The deeper physics has gone, the less the world has resembled a machine built for easy reading. It has become something subtler, more intimate, and more dynamic. What once seemed solid has become porous with uncertainty. What looked empty now trembles with the possibility of form. What felt certain has learned to speak in the language of probabilities and traces. And yet, none of this diminishes our story. It enlarges it. Because every one of these discoveries began with a person noticing something small and refusing to look away. A flicker on a screen, a pattern in noise, a result that did not belong. Science, at its heart, is the willingness to let the world correct us, even when that correction comes at the cost of our comfort. It is the maturity to live with the fact that understanding is not the same as control, and that uncertainty is not always a sign of ignorance. Sometimes uncertainty is the most faithful response to a reality that is still unfolding. The projector is still running. The light is still hitting the screen. The movie of your life and the movie of the cosmos are being rendered right now, frame by frame, record by record. But for the first time, you can see the light behind the film. You can see that the now is a precious, expensive, and beautiful creation. We may never see the whole block of time at once. We may never send those winning lottery numbers to our younger selves. But we have discovered something much more profound. We have discovered that we are not just victims of time. We are the ones who keep the clock. We are the ones who pay the price for the second. And in doing so, we are the ones who make the universe real. Stay curious, stay rigorous, and stay tender before what exceeds you, because the map is being rewritten every single day, and the most exciting chapters are the ones we haven't even had the expensive click to record yet. The mystery isn't a wall, it's an invitation, and for the first time in history, we're finally learning how to say yes.